Today's notes are all about finding the number of solutions that an equation has. So all the equations that we've been solving thus far, we solve, we work through all of the steps, we get down, and eventually we say like x equals 6. And we've been circling that, and we'll continue to do so. But notice x equals 6, when we say that, we mean that that is the only solution. We would have one solution in that case. And most of the time, when we solve a linear equation, which is what we've been solving, we have that one solution, and that's what we've been finding. But it's possible that we don't just have one solution. We could also have more than one solution. We could also have no solutions at all. So that's what today's lesson is on, is finding the number of solutions to our equation. We are going to start with a couple vocabulary terms, the first of which is an identity. An identity means that the equation is true for every value of that variable. So notice the example that is given, x plus 1 equals x plus 1. I have exactly the same thing on both sides of the equal sign. So notice if I plug in x equals 5, and I plug in 5, I get 5 plus 1 equals 5 plus 1, 6 equals 6. That's true. So x equals 5 is a solution. If I try x equals 0, I get 0 plus 1 equals 0 plus 1. Well, that's true. So x equals 0 is a solution. If I try x equals 1,264, if I plug that in, it would say 1,265 equals 1264 plus 1, 1265 on both sides. That is a solution. Anything you plug in for x, you can plug in -9, say -8 equals -8. That's a solution. Every value of the variable makes the equation true is called an identity. When that is the case, we state that there are infinitely many solutions. We have an infinite number of solutions. It is possible to have infinitely many solutions. We could also have no solution. We would have no solution if there is no value for the variable that makes the equation true. There is no solution. So if we are asked how many solutions a linear equation has, it's possible we have one solution. That's been the case most of the time, really all of the time. Anything you've done for this class, we've had one solution. It's possible that we have an identity, which would give us infinitely many solutions. And it's also possible that we wind up with no solution at all. And we'll be taking a look at how to tell when we have infinitely many solutions, when we have no solution. Example one is going to show us when we have infinitely many solutions versus when we have no solution. So example 1, we are given an equation here, 10x plus 12 equals 2 times the quantity 5x plus 6. The good news is there are no new steps in solving this equation or any of the equations. The entire lesson that we're doing today, we're solving equations the same way that we've been solving them. So here's my equal sign right here. Looks like I've got a number in front of the parentheses. So we are going to use the distributive property to do 2 times 5x and 2 times 6. And at this point, we usually combine like terms. If I check my right side, I don't have any like terms. My left side has no like terms. So last class we talked about if I have x's on both sides of my equal sign, I need to move them over to the same side, which we would do by subtracting 10x. 10x minus 10x cancels, so on this side I just get 12. And on this side, 10x minus 10x cancels, and I just get positive 12. Well, 12 equals 12. Notice all my x's went away. If all the x's go away, that's when I'm either going to have that infinitely many solutions or no solution. If I get down to a statement that's always true, 12 is always equal to 12. No matter what x is, 12 is equal to 12. In this case, we have infinitely many solutions. And you might have recognized a little earlier at this step right here, it says 10x plus 12 equals 10x plus 12. I have exactly the same thing on both sides of the equal sign. That is an identity, which tells us that we have infinitely many solutions. Taking a look at example 2, we have 9m minus 4 equals negative 3m plus 5 plus 12m. 9m minus 4 equals negative 3m plus 5 plus 12m. Equal signs right here. I don't have anything I can distribute. I do have some like terms on the right side of my equation. Negative 3m plus 12m. We should probably combine those up. Negative 3m plus 12m gives me a total of 9m. I've got m's on both sides of my equal sign. I need to move them over to the same side. I can do that by subtracting 9m from both sides. And similar to example 1, 9m minus 9m goes away, and I bring my 5 down. And 9m minus 9m cancels on this side also, and I bring my negative 4 down. And this doesn't always happen, but every once in a while, all the m's or all the x's cancel out. Notice on the previous example, I got 12 equals 12. 12 is always equal to 12. That is why we had infinitely many solutions. For example 2, my equation says negative 4 equals 5. Well, negative 4 is not equal to 5. No matter what m is, I'm never going to be able to make negative 4 and 5 equal to each other. So this is a false statement. There is no solution. There is no value of x that's going to make negative 4 equal to 12. Let's try a few more here. Number 1 on this one says 3a plus 5 equals 6 plus 2a plus a. Three a plus 5 equals 6 plus 2a plus a. Start by combining like terms. Would say 3a plus 5 equals 6 plus 2a and 1a make 3a. Move all your a's over to the same side. Subtract 3a from both sides. Cancels. Cancels. I get 5 equals 6. 5's not equal to 6 ever. No solution. Number 2 says 4 times quantity x minus 1 equals 4x plus 10 minus 14. Let's start by distributing the 4. 4 times x. 4 times negative 1. So we did the distributive property there. I've got a couple like terms right here that I can combine. Positive 10 minus 14 gives us negative 4. We can move our x's all to the same side. I get negative 4 equals negative 4. Probably should make sure we're doing the same thing on both sides every step. Negative 4 equals negative 4 tells us that there is an infinite number of solutions. Infinitely, I have an H in there. Infinitely many solutions. And finally, number 3. Number 3 says 3x minus 11 equals 4 times the quantity x plus 3 minus 1. 3x minus 11 equals 4 times the quantity x plus 3 minus 1. Start with the distributive property. This should be a plus 11. Sorry about that. Change that to a plus 11 in the initial problem, which means it is a plus 11 right here. Next step, I've got a couple like terms here to combine. 3x plus 11 equals 4x plus 11. Move all of your x's over to the same side. 3x and 4x, the smaller one's the 3x. Subtract 3x from both sides. We get 11 equals 1x plus 11. Notice my x's did not go away. Even though I've got 11s on both sides, this is not infinitely many solutions. My next step would be to subtract 11, and I get x equals 0. X is equal to 0. X equals 0 is a solution. If it says solve, we solved. X equals 0. If it asks how many solutions are there, there is one solution. And that one solution is x equals 0.